Gosh. You really need other things to focus on. Okay. All right. We're in good shape. Okay. Let's take a look at example 11. So we've got these 6 problems, and then the rest of the time I'll just let you work on 6-3. We'll finish this up tomorrow, and then you can walk out of here. No math to worry about over spring break. Have a good time and all that sort of stuff. So this is an equation that we need to solve. We want to find an x that makes this equation true. Right now, this is what we'd call a logarithmic equation because it's got a logarithm in it. Nice fancy name there, right? Okay, can somebody tell me what part of the logarithm this is? It's the base. The base is 6. Now, we talked about this before. Okay, remember up here when we filled these blanks in? The answer to a logarithm is a what? An exponent. Okay? So if this is the base and this is the exponent, how could we rewrite this to solve this equation? Shane?
6 to the second is equal to x.
6 to the second is equal to x. It's that simple. Okay, the point of solving an equation is to get the x on one side all by itself so you can read off the answer. Okay, we want to get a number that when we plug it in, it makes it true. So this says 36 is equal to x. So that is the answer. Okay, please be aware. Everybody listen. You do have to make sure that the answer that you get can actually be plugged back in and make the equation true. Okay, just like when we dealt with rational equations, okay, when we've got fractions, if you've got a variable in the denominator, you've got to be careful that when you plug it in, you're not dividing by 0. If you've got a radical equation, you've got to make sure you're not taking the even root of a negative. And when you're taking the log of something, you have to make sure you're not taking the log of 0 or a negative, because those are not in the, what's the word? Domain. They're not in the domain. Very good. Okay? Does this work? Let's just double check. Let's rewrite the equation with that in there. Log base 6 of 36. What exponent goes on 6 to make a 36? 2. So does it work? Got it. Okay? Let's take a look at this. Same type of thing. Here's the base. Here's the exponent. And there's the number that it should equal. So this is going to be x to the 1/2 equals 8. Now at this point, this may not be the most convenient way to think of this, x to the 1/2. What does that mean? Okay, to the 1/2 power, that rational exponent means the square root. So if you know what to do from here, that's great. If you don't, try writing it like this. Either way, how are we going to solve this? We're going to, thank you, Kang. We're going to square both sides. So if I square both sides, whether I have it in this form or in this form, what's x to the 1/2 to the second? Hold on. X to the 1/2 to the second. Power to a power, what do I do with the exponents? I multiply them. And what's 1/2 of 2? 1. So this is going to be x on this side, and this is going to be 64 over here. Okay, we're very familiar with the fact that these undo each other, so we get an x over here and a 64 over here. So whether you write it as a radical, or whether you leave the rational exponent and square both sides, you're still going to get 64. Does that answer work? It does, because log base, log base 64 of 8 is 1/2. In other words, 64 to the 1/2 power does equal 8. Okay. Any questions? Okay, would you do the next one, please? The next one's a little bit different than the ones we've done so far. When you're done, check with your neighbor. Make sure you both got the same answer, and hopefully that answer is right. Okay, when we solved example A, you write it in exponential form, and that is the answer, x equals 36. When we solved example B, when we write it in exponential form, we still have a bit of an equation to solve. So we had to square both sides to get the answer. When we write it this way, what type of equation do I get? What is it? It's an exponential equation. So 3 to the x equals 81. And we learned a couple sections ago, how do you solve an exponential equation?
Gotta make the bases the same.
You got to make the bases the same. So we're going to have 3 to the x equals, let's see, 81. How do you write that with a base of 3? 3 to the 4th. Very good. 3 to the 4th. So if the bases are the same, then the exponents have to be the same, so you get x equals 4. Okay? All right. Any questions? Okay, let me show you how to solve this a little bit differently. Okay, I think this is, in my opinion, I think this is easier, and in the long run, I think it's better. Okay, and let me show you why. Okay, when we wrote this, the square root of x equals 8, everybody knows that to solve this, we're going to square both sides, right? Because these two functions are inverses. Okay, look at this right here. This is log base 3. Okay. Log base 3 of 81. This is asking for the exponent that goes on 4. Or sorry, exponent that goes on 3 that equals 81, and that would be 4. Okay? So we could exponentiate both sides. What does this function do to this function? Undoes it. So we get 81 here, and we get 3 to the x there. It's the same thing. We end up with the same result. Okay? It's just thinking of it a little bit differently. Okay, any questions? Okay, let's keep that in mind on this one right here. So this is ln x equals 2. ln x equals 2. Okay, a few minutes ago we reminded you of what the n stands for. Stands for what? Natural number, or e. So the base of this logarithm is e. So this is log base e of x equals 2. Okay, and we want to know what x equals. Okay, this is log base e. What undoes log base e? What is it, Charles? Exponential base e. So we're going to do e to this side and e to this side. So if we exponentiate, that's the word here. If we exponentiate both sides, what does this function do to this function? It undoes it, right? So we get x over here and we get e to the second. That is the answer. As ugly as that is, that's it. E is just as good a number as anything else. So if this were 4 squared, that would be 16. This just happens to be e squared. It's kind of an ugly number. Remember, it's an irrational number like pi. Okay, any questions? Sure? Okay. Could we have done this? Could we have just said, you know what, this is ln x equals 2. This is in logarithmic form. The base is e. The answer to the logarithm is 2, so that's got to be the exponent, and the answer is x. We could have done that. They both produce the same answer, but this idea of exponentiating is an important one. Okay, are there any questions? Okay, would you do E, do example E, check with your neighbor when you're done. And then I'll call on somebody to tell us how to do this. Chase, what's our first step on example E?
You do 2 to the base of, or 2 to the power of -4.
Okay. Okay, he's using the right words there. 2 is the base. This is the answer to the logarithm, so it's the exponent. So that's, whoops, that's a -4. And then over here, what do we put, Chase?
8 to the power of x.
8 to the power of x. Okay. And then what do we do, Caitlin? Okay, we get the same base on both sides. Okay, now let me show you one other way to do this problem. What if I did, well, this is log base 2, right? What's the inverse of log base 2? Exponential base 2. So could I exponentiate both sides and accomplish the same thing? I could do 2 to this side and 2 to that side. So these two undo each other. There's our x to the 8, or 8 to the x. And over here we have 2 to the -4. Either way, you're going to arrive at this equation right here. which is an exponential equation that we already know how to solve, and Caitlin told us what we're going to do. We're going to write both sides using the same base. And that's pretty easy on this one, because we're going to have 2 to the negative 4, and 8 is what with a base of 2? Okay, 2 to the third to the x. Power to a power, we multiply those. So 2 to the negative 4 equals 2 to the 3x. If the bases are the same, what must be true of the exponents? They've got to be the same. So we've got negative 4 equals 3x. Divide by 3, and we get x equals negative 4/3. Okay? Any questions? Okay, last one. Let's take a look. Okay, I'd like you to do this one by exponentiating. So I've got to get this e to the 5x where I can work with it. Well, gosh, or do we need to do we need to exponentiate this one right here?
No.
Tatum. Very good. Would you say that again a little louder? Okay. Let's take a good look at this. This is a function. What's its name again? Natural log or log base, e. This is a function, exponential base e. What do these two do to each other again, Tatum? Undo each other. So this side is just 5x, this side's a 20. This is the easiest one. Even though it looks the ugliest, this is the easiest. We're going to divide by 5, so x equals 4. Now, if you've got a logarithm in a problem, you should always make sure that it actually works when you plug it in. So let's take this and let's plug that in right there and just double check and make sure that it works. So this would be the ln of e to the 20th equals 20. Is that true? Absolutely. Okay, because this is log base e, this is exponential base e. This side would turn into a 20. Any questions? Okay. Here is the assignment. Josh Noyce, what's our goal tomorrow when you leave here? Have it completely done. Okay, should we correct this?
Yeah.
Okay, if I'm not mistaken, some of you have a bunch of tests today, but not tomorrow. So if we spent 50 minutes in class tomorrow, you ought to be able to walk out of here. We should be able to correct this at the end, and you've got no math to worry about for 9 days. Does that sound good? Okay, let's do that. Get working on this. If you don't have a book, I've got one extra one here, or work with a friend. Get this done today, or at least leave enough that you can be done tomorrow and we'll correct.